Okay, we're going to look at lesson 3 in the radicals unit here at some of the homework questions. So if you take a look, page 300, question 6, we'll first do 6a. So we're at, it says isolate each radical term, then solve. So basically you always want to isolate the radical term, even if there's variables in other terms. In any equation, you want to isolate the variable. These radical equations have the variable in the radical. So by isolating, we're going to bring the 7 to the right. So that's going to be negative 3 root n minus 1 equals negative 21. Then if that coefficient divides into the right side, then divide it. If not, then you're dealing with fractions, so leave it, but in this case it does. And then you square both sides. You're trying to get n by itself, right? So opposite of square rooting is squaring. And then bring the 1 over, so n equals 50. If you take a look at the original, this actual question gave you the restrictions on n to start. So for sure, n has to be greater than or equal to 1. This is, but you still need to verify because there are cases, especially when there's n's or variables that aren't in the radical as well, that it may not satisfy it. So I like to use a t-chart. So it kind of looks like a T, separates the left side and the right side, because you don't really want to put it into the equation because you don't know if it's true. And you don't want to have an equal sign. So I write out what's on my left side. I substitute in the 50. I like to put brackets around what I substitute in. And then negative 14 is the right side. Then simplify. So that's going to be root of 49, which is 7. And so you notice that I put equal signs here for the left side work. Nothing to do on the right side, and then I'm not saying that they're equal because they might not be, but in this case they are. Left side equals right side, so that's our solution, n equals 50. Okay, next one, I'm not going to do C on that because it's kind of similar. Question 8, let's look at this one because you'll notice it has a variable in the radicand and a variable in just a variable term that's not square rooted. So in this case, you still want to get the radical term by itself, so 3x minus 5, and then we want to get rid of any other terms. So that's going to be x minus 5. You can't simplify that, but at least the radical's by itself. If you don't do that and you square the left side, then you'll have 3 terms, one of them being a radical, and that doesn't help you at all. So we want to square both sides. And when we do that, we just get the radicand. And then when you square this binomial, it ends up being 3 terms. So don't forget about that. So if you need to do it the long way, 2 binomials, and use FOIL, do it, whatever you need to do to get the correct answer. Now it's just a quadratic. So we want to, with a quadratic, get one side being equal to 0. So I'm going to subtract 3x from both sides. I'm going to add 5 to both sides. And so I'll have 0 equals x squared minus 13x plus 30. So then we want to solve. We can factor this. What I didn't do at the beginning, but looking here, the restrictions on x, 3x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5/3. So that can help us with solving. In any case, factoring here, we need 2 numbers that multiply to 30 and add to negative 15. So either both positive or both negative. So the only choice is negative 10 and negative 3. So x equals 3 or 10. So both of those numbers satisfy this, but we still need to verify. So I'm going to start with x equals 3. And what was my left side again? 5 plus 3x minus 5. So 5 plus root of 3 times 3 minus 5 here. And the right side was x, so that's 3. So that's going to be 5 plus, no, I copied something down wrong here, just a sec. Yeah, okay, that's right. And so here, 9 minus 5 is 4. So that's going to be 5 plus 2, which is 7. Notice how the right side here is 3. So the left side is not equal to the right side. So that is an extraneous solution. Let's try the other possible solution. So 5 plus 3 times 10 minus 5. The right side is 10. So 5 plus, that's going to be 25. Square rooted is 5. So this does work. So left side equals right side. So now we really just have, we only have one solution, x equals 10. So even though both of those satisfied this initial condition, it's basically because of the other x. It causes there to be restrictions on that. Now what you can do as well is graph on your calculator. So I think I've entered these. So when I like to check on your calculator, you have two choices. You can put the left side in as y1, the right side as y2, and see where they intersect. Sometimes if it's a really crazy equation, it's hard to see where that happens. So I like to bring everything to one side. So if I brought everything to the left here and graphed y equals, then I'm really looking for where y equals 0. Because when I bring everything to the left here, I get 0 on the right. So that's really what I'm looking for. So if I enter that in y1 and y2 is 0 and graph that, then with a standard screen, or I actually changed it to go x equals 12 because I thought my solution was 10, so I wanted to have a little extra space. And then you can see that it does look like 10. You can check second trace intersect. Notice how right now when it's on the radical, it's actually not on a point. So go to, you can actually see it on a point, and then enter on that, enter on the second curve, guess, and he gives you 10. Notice the other extraneous, when x equals 3, if I'm on my radical, I get a y value of 4, right? Not 0. So it doesn't intersect. Okay, so that's another way of checking. So, and then C is very similar to that. So now let's go to